Hi guys and girls, a video here on hypothesis tests according to the mean of a normal distribution. Key things to remember from when we did binomial hypothesis testing are the null, the alternative, and the condition for when you accept or reject your hypothesis. So your null we write as H0, and that assumes that there is no change in the mean. And the alternate is denoted H1. It can either be a one-tail hypothesis, in which case you're going to say that it is more than or less than, depending on the question, or you can have a two-tail hypothesis which says it's got to change, but I don't know if it's going to get bigger or smaller. So this one assumes change. And then the condition, by that I just mean is when is it that you reject the null? So when is it that there is enough evidence to say that something has changed in a way? So if the p-value, there's two ways to go about these. You can work out the probability of a particular value being significant, which is its p-value. So if p is less than the significance level, reject H0. So all that means is if I was to look at this little diagram, if I find that my particular test statistic is in that critical region, then I can say, yes, there's a change, up or down or two-tail, we don't know. If it is not, then we can't, we have to accept H0 and say that there's been no change. Just as a note, if you had a two-tail hypothesis, your significance level would have to be divided amongst your two tails. That's an awful curve, but it will do for the purpose of illustration. So if you had a 5% significance level and it was two-tail, this would be 2.5% and this would be 2.5%. Right, let's get on. I'm going to do both of these. I've got two examples both ways, so one with critical region. Actually, one of them works. I'll do one with critical region, one with p-value. So, first example. So the level of a chemical in water has a mean of 24 nanometers and a standard deviation of 6 nanometers. Two samples are taken with an average of 34 nanometers. Is this high enough at the 1% significance level to suggest the level of chemical has risen? Okay, so there's a few things you have to state before you start doing a hypothesis test. You have to state what it is you're measuring. So we are measuring the level of chemical, and we are assuming no change. So the mean, will be, what was it, 24? Or if there is a change, now this specifically says has risen, so that should be greater than 24. Right. So we have a test statistic of 32, and that was from two samples. So our distribution, X is distributed normally. We assume nothing's changed yet, so 24 is the mean, but the variance is the normal standard deviation, which is 6 squared is 36, divided by the number of samples you're taking. So it's written as X is distributed normally with mu and sigma squared over n, where n is the number of samples. And we are testing the probability that if our mean here is 24 and we want to know where 34 is, does that fall within our region? So we need to know that the probability of being greater than 34, whether that is more or less than our significance level. Quick tip, if I can get my highlighter, there we go. The symbol there is always the symbol there. If you're testing higher, then you've got to find probability of being higher. Right, so you're going to need your inbuilt calculator functions for that. You should go to, it's mostly written as normal CD or normal CDF, depending on which calculator you have. You set your mean to be 24, you set X to be 34, and you set the sigma to be root 18. And what your calculator will do is actually it will do less than or equal to your test number. So what we're actually going to need to do is this. All right, we want it to be greater than, so we need to take away everything less than or equal to. And by my calculation, that comes out to be 0.00921. So we need to know, is 0.00921 bigger or smaller than 1%? Well, it is smaller. You will get a mark for stating that, even though it seems obvious, so put it in. Then you have to state what you're going to do. Are you going to reject the null? Are you going to accept the null? And you must put it in context. So to finish this off, we could say, since this inequality, we reject H0 in favour of H1. Now put your context by it. So this means that there is enough evidence, or that there is significant evidence, you learn these passages off by heart after all. This means that there is significant evidence at the 1% level to suggest the chemical level has increased. If you do not mention that word chemical, or even chemical in water would be probably better, you will lose marks. Don't forget your context. So the other way to approach it is to say, well, what is the cut-off? If I know what the cut-off is, then anything where it's either more or less, depending on the tail of it, that's I'm going to be able to tell straight away rather than calculating every single one. So that's what I'm going to do with this one. So the temperature of a toaster has a mean of 60. So X is distributed normally with a mean of 60 and a standard deviation of 1. The temperature was measured 5 times. So my standard deviation, my variance is 1 over 5. At the 5% significance level, what range of temperatures will provide evidence that the mean has changed? Right, so the thing that we are measuring is the temperature, and we are saying H0, the mean is staying at 60, and H1 is that the mean. Now we don't know if it's going up or down, but we certainly know it's not going to be 60. This is a two-tail. So in my diagram, I find these diagrams always help. So I've got my mean here of 60, and I need these two tails here to sum to 5%, so I've got 2.5% here and 2.5% here. And we are going to do it by finding these cut-offs. So, how are we going to tackle that? Well, we're going to need to know, if we take the lower tail first, so the probability that x is less than the first value, that has to be equal to 0.25. So if we can use the inverse normal distribution, so we know the area under that particular tail there is 0.25, we know the mean is 60, we know the standard deviation or sigma is root 1 over 5. So if you pop all that into your inverse normal distribution, so that would be I missed a zero, it's 0.025 for 2.5%. 0.025, so you pop it all into your calculator and that comes out as 59.1. Now you could do the top end and say that you're going to do the inverse normal of 97.5% and that will give you the top cutoff, but there's an easier way. These are symmetrical, so if this has gone down to 59.1 from 60, then you have taken off 0.9. So this one must have gone up by 0.9, so that must have been your top level. So you can say from 59.1 to 60.9, that is in the acceptance region, so it's accept the null. So if x is less than 59.1 or x is greater than 60.9, we reject the null. There you go. So the question was, what range of temperatures will provide evidence that the mean has changed? And it would be those ones there. There you go. Hope that made sense. Bye.